If your DHT11 or DHT22 sensor shows NaN or random values, you're probably making one of these mistakes. First, it doesn't even compile. The sensor type is missing, so the code fails before it even starts. You add the sensor type. Now it compiles, but the output is just NaN. At this point, you realize the sensor type doesn't match your hardware. So you fix the sensor type, and it still shows NaN. Why? Because the sensor needs time after initialization, and without that delay, the first read can fail. You add the startup delay, and it still shows NaN. This time, the problem is the loop. DHT sensors need time between readings, and if you read them too fast, they stop responding reliably. So now there is a delay in the loop, but it's still not enough. DHT sensors need more time between readings, and if that delay is too short, the sensor still fails. So even though the code looks better, the result is still NaN. Finally, you increase the delay, and now it works. The sensor starts returning valid temperature readings. But getting here wasn't exactly simple. Now, let's start over. Instead of fixing all of this step by step, we'll use a library that handles it for us. All you need to do is include the library. No need to specify the sensor type, no need to add a delay after begin, and no need to manage timing in the loop. Everything is handled internally, so the sensor just works. If you want your DHT sensor to just work, you can find the library in the description. And if you want to understand why these sensors fail, there's a full guide below.